Hey students, in this video I'm going to go over the domain and the range of absolute value functions. So just to recap of what domain and range is, domain is the vocabulary word we use to represent all possible x values of a function. So instead of listing each x value that is being used on the graph, you just write a notation that represents all x values. And same thing, but we're using the word range, we're going to represent all y values. So one way we can remember domain and range, which one represents which one, I believe it's Dixie Royd, what I've shown my students before. So if you can memorize Dixie Royd like you can memorize PEMDAS, you can memorize that domain represents the x in the x values, and range represents the y values. So it's Dixie Royd. Also, another thing I tell my students is to right away, as soon as you see domain, kind of sketch left and right. And if you see range, sketch up and down. So you can recall which values to look at. Here we have the vertex form of absolute value functions or equations. And in this case, it's called vertex form because the vertex is created by the h and the k values that are found right here. So anytime you have an equation, you don't need to graph it all the time. You can just look at it and find the vertex by looking at these 2 points, these 2 values, but just make sure it follows the template of x minus a number. That's the tricky part. Another way you can also find the domain and range without graphing is by understanding that if the a value is positive, the graph's going to open up. If the a value is negative, the graph's going to open down. So just a visual of sketching things to yourself when needed without needing to graph them in the calculator. You just basically need the vertex and whether it opens up or down to know how to write your domain and range. So here's an example of each accordingly. Now, there are a couple new notations in this level of math. This right here is a new notation for you guys. So you need to know how to say this in words. So all of that means the set of x values, and then this line right here means such that, and then this part over here, we can say x is an element, the E stands for element of, and then the R like that stands for all real numbers. So this is why mathematicians learn to speak with symbols and signs and notations, because they're not going to sit there and write all these words when they could just write that notation. So you need to teach your brain to speak the math language and understand that when it's in this notation, it is saying the set of all x values, because there's an x right there, the line that goes vertical like that is such that, and then whatever happens to be after, it's what is the domain. So in this case, this is just saying that the domain for this graph right here is all real numbers. So let's talk about real quick why is the domain for this graph all real numbers. Domain, once again, you're going to look at it left to right. You're going to ask yourself, what is the minimum, meaning the smallest x value that you're using, and the maximum, the highest x value that you're using. So the fact that this graph goes left forever, this is never stopping. There's going to be an x value here, an x value here, an x value here, and in between there are more points, and in between those points there's more points. So you're never going to really list them. You're just going to write a notation from here to here if it stops. But in this case, this graph goes on forever to the left, and then it goes on forever to the right, resulting in you writing that you have a negative infinity as your minimum, because it's going to go forever left, and then a positive infinity to the right, going forever to the right. So instead of writing the negative and positive infinity all the time, we can write this notation that says that the x values in this graph are an element of all real numbers. So any number you can think of is an x value that is being used. Another notation is called interval notation, and it looks like this. You're basically putting a parentheses or a brace on the end. Parentheses is there if it's never touching, and a brace is there if it is touching. So kind of like below, you see a little brace right here, a little bracket. In this case, we have parentheses on both sides because the graph is never stopping. So we just assume parentheses representing going to the left forever. So the minimum will be left and the maximum will come after. So minimum, comma, maximum. And then you just decide whether to put parentheses or brackets or vice versa. So again, parentheses is not touching, and brackets means it's touching. It's stopping there. So sometimes you may need the brackets. So set builder notation, you have those little curvy braces, x such that x value element of all real numbers, and then interval notation. This is saying the same thing, it's just written differently. This is saying that it's going forever left, forever right, and not touching or stopping. So that notation is practiced throughout this whole video and anytime you need to write domain and range in any function we study. So this is probably just new to you right now, but hopefully with practice it gets better. For the range, this is the set builder notation for the range for this graph right here. Remember, domain is left to right, range is up and down. We're looking at the maximum value being on top and the minimum being on the bottom. So if we look at this graph, we know up is going forever and down, this vertex tells us the lowest point that it's going. So the vertex itself is -2, but only the y value tells us what that lowest point is. That's what we need to recognize this as a minimum or maximum. In this case, we have a minimum. So in our setup here, we know that the range is going to have a minimum of 1, and the maximum will be infinity. Because again, the graph is going up forever, and the lowest point is a y value of 1. So when we write that in a notation, we just want to say same thing over here, the set of all x values, but now it's going to be the set of all y values. I'll just write it down. The set of all y values, and then the line like that is such that if we continue saying this part, we're going to say all y values, or such that y, we can just say such that y is greater than or equal to your k value. So your k value, again, the h, and k come from there, and the k value is your minimum value, so that 1. So right here, just speaking in general terms, your k value goes there. But if we were to write it for that graph, it will look like y is greater than or equal to 1. So I'll just write k value for now. For interval notation, because your k value is your minimum, so again, the lowest the graph got was 1, you will have a minimum of the k value and then the maximum after. And because it is stopping at the minimum, you will write brackets, and it is not stopping at the maximum, so parentheses. So again, the graph's opening up, there is a minimum value. Whatever value that is goes here. And then comma your maximum. The maximum is going to be infinity because it goes up forever. And you just got to write that bracket where the minimum is at because it's stopping there. But a parentheses on the maximum because it goes on forever. So on the right side, you have the same setup here where you write the domain for this graph. This is going left and right forever. Even though it's facing down, your description for domain is left and right. So this graph is going left negative infinity forever, and then right positive infinity forever. And the interval notation is just easy to write because it's just writing those numbers. Negative infinity to positive infinity, parentheses on the sides because it's never stopping, and then comma in between because it's in minimum, comma, maximum mode. The set builder notation, though, I know it's not something you're comfortable with writing yet, but all you really got to emphasize is that the domain for absolute values will always be written like this because it goes up left and right forever. So the set of all x values such that x is an element of all real numbers. All right, for the range, because this one, for range, we're looking at it up and down, is going to have a stopping point at the top. The vertex will still tell you what that highest value is. No, it's a maximum because it's the highest in the graph, and that too is the k value of your vertex. So like right now, this is 3, 2, and then that k value is the value we're going to use to represent the maximum, the highest that it goes. So notice right here, we have the notation again of the y, the set of all y values such that y, now instead of greater than or equal to, we're going to have to say less than or equal to, because now we're looking at having a maximum value, so nothing can be greater than that. So then now we have less than or equal to that k value. And then we have the interval notation of that, still following the template of minimum and maximum. Remember, the minimum is the lowest, the maximum is the highest on range. So lowest is negative infinity because it's going down forever. And then highest is at 2 because it's stopping there. So here it has k, but that would be like a 2 if we represent this graph. Bracket on that number 2 representing that it's stopping there. And then parentheses for negative infinity because it goes on forever. So now we just practice. Because it's a video, I'm just going to go over the examples on the left side. And I'll try to go quickly since it's already a 13-minute video so far. All right, so we have a graph that seems to be going up forever. So right away we know on our range we have highest infinity because it's going up forever. And then lowest, this vertex tells us what the lowest k value is, or the y value, which is 4. So it's a minimum. -4 to be specific. For domain, we're looking at it left and right. So the arrow is going left forever, right forever. So it's negative infinity, positive infinity. All right, for set builder notation, we're going to write the little curvy braces and then x such that x is an element of all real numbers. So it's going left and right forever. That means every number is being used. For interval notation, following the minimum, comma maximum, minimum is negative infinity, maximum positive infinity, parentheses around because it's never touching. All right, for the range, we're going to write that notation, but with the letter y, because it's a range. So y such that y, we're not going to write element of real numbers because this does stop. It doesn't go forever left and right. We know that the minimum is -4. So we need higher. We need greater than or equal to -4, and then the bracket symbol. For interval notation, we're still going to follow the minimum comma maximum scenario. And again, lowest is your minimum, maximum is infinity. So -4 comma infinity. And then -4 is a point where it's stopping. That's the lowest it gets. So we put that little bracket and then parentheses over here. So again, hopefully you're rewinding, stopping the video to kind of understand more at where we're getting these numbers from. But let me go ahead and continue with the next example. Here is another one facing down. So here, this turning point, this vertex will be a maximum because that's the highest that this graph goes. So right here at 2, that will be your maximum point or value. So when doing range, 2 will be the highest it goes, and then -infinity is the lowest it goes. For domain, left and right, arrows go left and right forever. So that will stay positive and -infinity. So the domain is going to be repetitive. All absolute values create that B. So we're just going to write x such that x is an element of all real numbers for the domain. Or we can write -infinity to +infinity for the domain. For the range, though, this is where it's going to differ based on how the graph opens. So now our set builder notation will have to represent y such that y is less than, because now we have a maximum of a 2. So less than or equal to 2. And then we'll close brackets. And then we have interval notation, minimum, comma, maximum. The minimum is -infinity. +2 is our maximum. It is stopping at 2. So we're going to have that bracket and then parentheses on the side. Okay, on this one, we don't have a graph given. So this is a part where you could use your calculator, or if you don't have one, just do the reasoning behind the A value and the H and the K. So A value is in the front, outside of the absolute value. A is negative. So when the A is negative, that means we're going to have it opening down. So our vertex is going to be a maximum value. These are the ones that give us the value of the vertex. The vertex is HK. The vertex form follows x minus h. If we don't have x minus a number, that means that we have x minus a negative number, and then plus the k. So our h is -6, and our k is -5. So if that vertex is right here, our maximum value is this y value of -5. And once again, the domain will not change. It goes left and right forever. So we are going to have x such that x is the element of all real numbers. And then -infinity to +infinity. And then for the range, we do want to emphasize that our highest value is -5. So y such that y has to be less than or equal to -5. And then as far as the interval notation, it's minimum, comma, maximum. Minimum will be -infinity. -5 will be our maximum because that's the highest that it goes. That number is going to stop there, so we put the brackets and then parentheses over here. But of course, let's graph it and check just so you can see it. We're going to have, let me see right here, -4, absolute value, x plus 6 minus 5. So it's down here. I'm going to go ahead and zoom out a little bit. All right, so we're going to notice that right here, that vertex, we can trace it. Nope, let me do trace. And then the maximum it tells you is -6, -5, which means that -5 is the y value. And then also it's going down forever and to the left and right forever. So it's kind of like the sketch that I have right here. So this is enough for you to find the domain range, just a little sketch of how it's opening and where that vertex is at. Okay, let's do one more example together. The A value is positive, so that means it's going to open up. And the vertex is going to be a minimum value because it's the lowest point. So HK is the vertex, X minus a number, and that number will be just 8. And then plus K, so that K value is 7. So that's your vertex. For the domain, it will never really change unless it stops at a certain extent. But these are just functions, so they're not going to stop. It's just going to go left and right forever, creating the all real values, all real numbers, -infinity to +infinity. But the domain, I'm sorry, the range is the one you got to think a little bit more of. So we're looking at a minimum. The y value tells us the minimum. And we're looking at writing that it's all y values that are greater than that, because 7 is the minimum. So set builder notation, and then minimum comma maximum. Minimum is 7, so the maximum has to be +infinity, and the 7 has to have those braces or brackets. All right, I hope you can understand this a little bit better, and go ahead and practice with the problems on the right side.